In this lecture, we are going to talk about the operator precedence and associativity. Now, first of all, let's learn what is operator precedence. Now, whenever in an expression there are multiple operators occurring, then you need to decide which operator will be grouped with which operand. In that case, we'll look at the priority or the precedence of each operator. The priority of each operator is already decided by the C language standard. So we are going to follow the same order in order to evaluate any expression, and even the compiler is going to use the same order that is specified in the standard to actually evaluate the expression, right? So let's look at the operator precedence and associativity rule as per the standard of C language. Now this is a table that represents all the operators available in C along with the description in the second column, and if you just look at the third column, that is the priority is or the precedence. Okay, so the operator at the top, that is these four operators: the function call operator, array subscripting operator, membership access operator using the pointer and the name. All these operators are having the same priority or the highest priority, that is priority number 1. So whenever you are having this kind of operator, that will be given the highest priority for grouping the operator with the operands. Okay. Similarly, these are the list of unary operators which is having the second priority. All these are unary operators: logical negation, logical not, bitwise complement, increment, prefix, postfix, and all these operators having the priority number 2, second priority. Similarly, multiplication, division, modulus having priority 3, and then the priority for addition and subtraction, that is priority number 4. Okay, priority number 5 for bitwise left shift and bitwise right shift. Priority number 6 for the relational operators as specified here in the table. Priority number 7 for relational equals to and relational not equal. So these are having, both of them are having the same priority, that is priority number 7. Similarly, bitwise AND is priority 8, bitwise XOR is priority 9, bitwise OR is priority 10, logical AND is priority 11, logical OR is priority 12. The conditional operator that we are going to discuss in our subsequent lectures is having the priority 13, and assignment operators, both direct and compound assignment, all of these are having the second last priority, that is priority number 14, and the comma operator is having the least priority, that is priority number 15. Okay, now this is the priority rule that is specified by the language. Now let's get back to our example. Now in this example, if you can see the first one, example number 1, we have 18 plus 2 times 3. So we have multiple operators in this expression. The first operator is plus and the second operator is multiplication, right? Now we need to decide, the compiler needs to decide which operand belongs to which operator. Okay, that is what the compiler needs to decide. So for grouping which operator is associated or binded with which operand, we use the rule. So if you have plus and multiplication, if we go to the table here and see, plus is having the lower priority than the multiplication. See, multiplication is having the higher priority than plus. So here multiplication is having the higher priority and then the priority of plus comes. So first multiplication will be given the more priority. So binding or grouping is done first for multiplication. So just look at multiplication operator here, asterisk. Whatever comes to the left of multiplication, 2 would be the first operand of multiplication and 3 would be right operand for multiplication. So this is how it is associated. 2 multiplied by 3 is evaluated first, and then for plus, the first operand would be 18 and the second operand, right operand, would be the answer of 2 times 3. Okay, so this is how the ordering is done. Now if I evaluate this, the answer would be, so it is 2 times 3 is evaluated for, this would be 6. So this is 18 plus 6 and the answer is 24. This is how the answer is evaluated. Okay, now let's look at example number 2. In example number 2, we have division and multiplication. Just let's look at the priority for division and multiplication from the priority table. You can see here both division and multiplication are having the same priority, priority number 3. So whenever the operators are having the same priority, how are we going to do the grouping? In that case, we'll be looking at the last column, that is called as associativity. Whenever the operators are having the same priority, Then we look at the associativity rule on how to associate the operator with the operand or how to do the grouping. Alright, so if you look at the associativity for multiplication, division and modulo, okay, having priority 3, it is from left to right. So let's get back to our example. So here we'll have to associate it from the left to right because both of them are having the same priority. Now we go for the associativity rule. So we do the grouping from left to right. Whenever we scan this particular expression, we'll first of all get the excess of division. So this is grouped first. So for division, the first operand is 18 and the second operand is 2. So this is how grouping is done. And then we do the grouping for modulo. So this is how the left operand for modulo is the answer of 18 divided by 2 and the right operand is 3. Now let's try to evaluate the answer. 18 divided by 2 is 9. This is 9 mod 3. Okay, for mod the first operand becomes 9 and the second operand becomes 3. So if I divide 9 by 3, the remainder is 0. So finally the answer for this entire expression is 0. This is how the evaluation is done. Okay, so it's very important for you to note down what would be the precedence and what is the associativity rule for all the operators. Now let's look at example number 3 wherein the expression is given here. So now in this expression we have 3 operators: plus, minus and multiplication. Out of these 3 operators, multiplication is having the highest priority. So first multiplication should be grouped. So for multiplication, the first operand is 6 and the second operand is 4. This is how it is grouped. And then plus and minus is having the same priority, right? So therefore we'll have to look at the associativity rule for plus and minus. It is from left to right. Okay, so we'll have to go from left to right for doing the association. So first of all, I encounter plus if I move from left to right. So for plus, left operand is 2 and the right operand is 3. This is how its grouping is done. And then we get this minus. So for minus, the first operand is the answer of 2 plus 3 and the second operand is the answer of 6 times 4. This is how it is done. Okay, now once grouping is done, this is evaluated to 24. Okay, this is minus and this is evaluated to 5. So this is 5 minus 24, which is equals to minus 18. Alright, this is how it works. Now there's a very important point to note here. The order of evaluation is not specified by the C language. Meaning, now for example, for minus, for this operator minus, the left operand is the answer of 2 plus 3. Okay, and the right operand is the answer of 6 times 4. Now whether you do 6 times 4 first or whether you do 2 plus 3 first is not determined by the standard. Okay, so in this case the first scenario can be, first compiler may evaluate 2 plus 3 first, so it will be 5 minus, and this one 6 times 4 second, 24. This can be done in this sequence, or it can be also done in this sequence. First this is evaluated, so 24, and then 5 is evaluated second. So the order in which the evaluation is done is not specified, although in both cases the answer is minus 18, right? So there is no change in the answer, but the order in which the evaluation is done is not specified by the language, so that is left upon the compiler to decide on. So very important point to note down from this slide is that the order of evaluation of the operators is not specified by the language. Now let's look at example number 4. In this example, we have this less than operator. There's just one operator available. So we'll have to look at the associativity rule. It is from left to right. You can look from the table. So first this one is evaluated and then this one is evaluated. Alright. So first of all, 20 less than 3. Is it true or false? 20 less than 3 is false. So it is 0. 0 less than 19. False is 0. Okay. 0 less than 19 is true. Therefore, the answer is 1. 1 means true. So this is how this one is evaluated. Now let's look at example number 5. In this example, there are 2 operators, less than operators and equals to operator. Less than operator is having the higher priority, so this is evaluated first. Only then equals to is evaluated. So first priority is given to less than, and second priority is given to equals to. Okay. 30 less than equals to 5. This is false, so it is 0, and equals to 1. So 0 is equals to 1 is false. So therefore, if it is false, the output is 0. Okay, so output for this entire expression is 0. Now let's look at this example, example number 6. In this example, we have following operators: not, less than, and not equals to. Okay, so out of all these operators, not is having the highest priority. So this is given the first priority. Okay, and then less than is given the next priority. So less than is given the next priority. and then not equals to given the last priority, not equals to given the last priority. So this is priority number 3, the last priority. This is having the first priority, and this is having the second priority. So first of all, not of 5. What do you mean by not of 5? 5 is nothing but a non-zero value. So 5 is true. Okay, 5 will be treated as true. So what is not of true? What is negation of true? It is false. So false means 0. So not of 5 is 0. 0 less than minus 2. This is not equals to 1. Okay. Now we have to do with this less than. 0 is less than minus 2. It is false, right? This statement is false. So the output is 0. 0 is not equals to 1 is a true statement. 0 is not equals to 1. So finally the output is 1. So 1 is the output for this particular expression. This is our last example. In this example, we have declared one integer variable n having the value 3. And we are trying to display two arguments here in this printf. The first one is we are displaying plus n, and the second argument is we are trying to find the power of 2. That is, we are trying to find 2 to the power n. In this case, we are trying to find 2 to the power 3 because n is 3, right? But before actually calling this power function, we are also doing plus n, right? Now let's see what is the answer. Now what do you think could be the answer for this? Most of us may think that, first of all, n is incremented by 1, so plus n makes n as 4, right? And 2 to the power 4 should be 16. So answer should be 4 and 16 as per it looks like here. Let's see how it behaves. So the output is n is 4 and the 2 to the power n is 8. It is not 16. Okay. The reason here is, as we have already discussed, the order of evaluation is not specified by the language. Okay. So although this comma is separating these two arguments, it is not guaranteed that whether this power will be evaluated first or whether plus n will be evaluated first. Okay. If power is evaluated first, in this case, n is treated as 3, so 2 to the power 3 would be 8. So in this case, this is evaluated first. So therefore, we get 2 to the power 3 as 8, as the power of 2 to the power 3 is 8 is the output, and only then plus n is evaluated. So the order in which the operands of the operator is evaluated is not specified. Okay, it can be evaluated in any order, that is left up to the compiler. Okay, in some of the compiler you may get a different answer for this particular scenario. Okay, so it's always good to write a code, write an expression which does not depend on the order of evaluation. Okay, so I'm pressing this point one more time, right? So order of evaluation is not specified by the language. Okay, that is, language does not specify the order in which the operands of the operators are evaluated. That is left up to the compiler to decide. So do not write an expression like this. So if you are trying to mean this, so first of all you can actually rewrite this as plus n here. Okay, and then make this as n and power 2 comma n. So here you are not depending on the order of evaluation, right? Whatever may be the order, always you are going to guarantee that the answer would be same, right? So let's try to evaluate this. So in this case, you see, first of all, at line number 12, I am incrementing the value of n by 1, so n becomes 4. Now I am trying to have two arguments here, 4 and 2 to the power 4, so it will always guarantee me the answer as 4 and 16 because 2 to the power 4 is 16. So whenever it's not a good programming practice to write a program or write an expression which depends upon the order of evaluation. So that's a bad programming practice. So whenever you have to do something like this, as you have stated in the example here, please make sure that your expression is not dependent on the order of evaluation, so that you break down the expression so that you always guarantee the same answer in all the compilers. Okay, so that's all in this lecture. I hope you have learned what is operator precedence, what is the operator associativity, and most importantly the concept that order of evaluation is not specified by the language. Therefore, you are supposed to write an expression that does not depend on the order of evaluation. That's all in this lecture. Stay tuned.